Hello everyone, here's Xinye Li from Tongji University, China, and the paper name is Parametric Design of Aluminum Alloy Joint Systems Applied in a Gridshell Roof Case. First about the introduction. The project is located in the planned Shanghai World Expo Cultural Park, and the greenhouse garden is constructed on the basis of the original structure of the Shanghai Iron and Steel Factory. Greenhouse garden will be adhering to the construction concept of green and low carbon. We will run with the old factory building. The green garden contains 3 greenhouses, and the structure system is a spatial tension string girder structure system with irregular ring-shaped aluminum roof. This ingenious roof form is composed of circular aluminum alloy structures in different sizes, as shown in the picture, and the piped part is the junction of aluminum poles whose intersection angle varies in certain range. To figure out the mechanical performance of this joint, parametric model is established, and finite element analysis has been applied, which provides reference for further detailed optimization arrangement. Under the guidance of different mechanical properties, this new type of joint is designed, as shown in the figure. Some of components, such as pi-shaped stiffener, I-shaped bearing stiffener, and L-shaped shear connector, have been added here for improving the out-of-plane loading capacity, and enhanced this joint's ability of applying in complex loading cases for complicated structures. Design styles are elaborately listed in the table on the right part. With the complexity of construction requirement, the traditional manufacturing process has been unable to meet, and the emergence of digital control has brought the possibility. We chose the whole process parametric digital analysis method to explore its feasibility and necessity, and prove the dominant superiority of parametric control digital design in such cases. As a result, the custom Python scripting has been adopted for establishing a linkage between these processes, including Rhino, Excel, and IASS, just as shown in the right part. The Python scripting constitutes 2 steps. First, transfer the concept design and geometric requirements to structure geometry in Rhino with Grasshopper, and extract the K parameters stored in Excel. Then, the data in pre-processing storage will be delivered to IASS for further numerical analysis, and the result will be extracted for making visualization results, which is called post-processing. The whole process constitutes a heterogeneous data exchange. The framework of this method is illustrated as the figure shows. The automatic generation of geometric model is established in Rhino's visual programming plugin Grasshopper, which supports Python and other custom programming with high flexibility. Combined with the constraints, 10 groups of intersection angle models were selected at an interval of 10 degrees for future finite element parametric analysis. Part of the parametric result with intersection angle as variable is shown in the picture. Under the framework of the parametric analysis above, the influence of 3 parameters on the varying performance of the joint are discussed here, which are geometric parameters, intersection angle, and loading parameters, pose an axial force and in-plane shear force. The axial force was selected from 0 to 800 kilonewtons, interval with the geometric form of the joints unchanged and the shear force content. The load displacement curve calculated by finite element method is extracted, shown as the left part. It can be seen that the relationship between the out-of-plane bearing capacity and the joint under the axial force of less than 600 kilonewton basically shows a linear change, and the platform appears in the range of 200 to 300 kilonewton, indicating that the out-of-plane bearing capacity is not sensitive to the change of axial force within this range. The influence of the in-plane shear force on the out-of-plane bearing capacity of this joint is studied in the same way as the above research method. The controlled variable method with the geometric form unchanged and axial force constant is adopted to select the shear force from 50 to 500 kN interval for finite element modeling calculation. The out-of-plane bearing capacity of the joint shows an obvious downward trend after 200 kN and 350 kN. In addition, we studied the influence of geometric form on bearing capacity. Based on that, 10 groups of intersection angle models were selected at intervals. The relationship between the bearing capacity of the final calculation result and the two intersection angles as variables were extracted, and the suggested three-dimensional curved surface was fitted by MATLAB, which clearly showed the change relationship among the three. Finally, about the conclusions. This paper summarizes a set of effective parametric analysis methods in Python framework, which provides analysis experience for the parametric optimization design of complex geometric structures. For the project of Shanghai World Expo Garden, the analysis of this paper has given the suggested value range of the interval force level and the geometric form of the joint under these complex loads. Future work will focus on finding the most appropriate algorithm of multiple parameter optimization of the design scheme. That's all. Thank you.